So this is the second experiment. So we will start by a brief introduction to talk about the solar module that we are using at the lab. So we have the solar module consists of many solar cells. So what is the solar cell? As we said last time, it consists of many parts. The most important part will be the effective material where the electricity is being generated. But we have a conventional crystalline silicon solar cell is look like something like this one here. It has these bars or bus bars, which are the made of silicon, and you have this blue thing here. The blue strips here are the printed on a silicon wafer, which is our effective medium. So this is our solar cell. This, when it is exposed to the sunlight, it will generate a voltage of about a half volts. um, Most photovoltaic cells, the voltage is constant, the current is proportional to the size of the cell and the intensity of light. Now, our solar panel that we are using at the lab is something look like this one. Uh, so uh, so uh, uh, it consists of many cells that are connected in series, in a certain way, in series and in parallel to make you a module. Now, the panel consists of um, one or more PV modules, and a photovoltaic array is a complete power generating unit, consists of a number of PV modules and panels. Um, so types of the solar, we have many types of solar cell. We have the monocrystal panel, polycrystal, and the thin film amorphous. Uh, Now, the first part, the monocrystal part, is has the highest efficiency. Um, it has many advantages, like as we said, high efficiency. It has a high lifetime, but it is expensive. For the polycrystalline one, it has a lower efficiency and a lower price, of course, but it is sensitive to high temperature. And we have this is the cheapest one. It has the lowest efficiency, and it has a lower lifetime. So when you need to use a solar panel or solar array, it uses the solar region. So because shading only a small part of the solar panel will cause a very big decrease in the power. And maybe so about one of 36 cells, if one over 36 cells is being shaded, it will decrease my power to 75%. And to understand this, you can compare your solar cells. As we said, they are connected in series. We can compare them to the water pipe. So if I have something that stop the water here in the water pipe, this affect the whole water flow. And this same thing happened when I have one of these cells covered or shaded. This cell that is covered will act as a resistance. um, this resistance will cause also an increase in the temperature and may damage my solar panel. Um, So every cell has to operate at a current set for a shaded set by the shaded cell. This will prevent the unshaded cell from operating at its maximum power. So therefore, only a small amount of the shaded cell have a dramatic effect on the power output of the solar panel. And now this can apply to the PV modules connected together. So the current flow through an entire string of modules can be heavily reduced um, because of one single module is shaded. Uh, so what can I do to prevent this effect, and to prevent the most important thing is prevent damaging this solar panel. As we said, covering one of them make it as a resistance. This resistance increase the temperature of this part, and it will be damaged and damage the whole panel. So what can I do to protect my panel? One way of doing this is using the bypass diode. So as you can see, this is I have this row of solar cells. If each square is a solar cell, and these are the rows that are connected in series. Uh, I can add a bypass diode that will allow the current to skip over the shaded region of the modules. So it will prevent this part from getting heated. But the problem of this is I need to use a diode for each cell. So I can only skip the shaded cell. But because the cost of this process, it's better to use this diodes for rows. So for example, if I have a 60 cell, it's better to use a diode for each 20 cell. Now the problem for this, even that it protects my panel, it will just make me lose um, power, because if I have, for example, these only shaded, this diet will cause to just cancel all this row. So I will lose the rest of the unshaded part of these rows. Now, two types of the diet are used: the BN junction silicon diet and the Schottky barrier. Again, choosing one of them depends on your situation. So the Schottky barrier diets has much lower forward voltage drop. It's about zero point 0.4 volts, but the BN diets has higher drop in the voltage is zero point 0.7. um, so as we said, if I have the now if I need to talk about the partial shading. Shading half of a cell is the same as shading half of a row, because these are all connected in series. So one cell or half of the cell shaded, that means skipping all the row that is or the whole row that where this cell is presented in. uh, and again, a full cell is shaded, this will make this cell try to protect itself and reduce the power to half of it. Now, in the lab, in the experiment that you will see, the record that you will see, you can take the measurement, or the measurement that we make by shading partial of a row, half of a row, whole rows, and different things, and you can draw and plot um, the relation between the shaded percentage and the voltage, and see how this affect the performance. Thank you.